Today's LeetCode problem of the day. Number 1727. Largest submatrix with rearrangements. Medium. Let's break it down simply. You have a binary matrix, only zeros and ones. You can reorder the columns in any order you want. Find the largest rectangle that's completely filled with ones after rearranging. Return its area. Here's the original matrix. The best block of ones you can find right now is just a column of 3. Area 3. But watch what happens when we move the columns around. Slide the column with the most ones to the left. Now rows 1 and 2 have 2 consecutive ones side by side. That's a 2 by 2 block. Area 4. That's our answer. Now here's the key insight that makes this easy to solve. For every cell in the matrix, count how many consecutive ones are directly above it, including itself going upward. A 0 resets that count to 0. We call this the height. Take the original matrix and transform it into a heights matrix. Row 0 stays the same. Row 1, each cell adds 1 if it's a 1, or resets to 0. Row 2 builds on top of row 1. Now every cell tells you how tall a column of ones you can form ending at that row. Now for each row, sort the heights in descending order. Biggest height first. This is exactly like rearranging the columns to put the tallest ones on the left. Sorting does the rearranging for us automatically. Once sorted, for each position in the row, the area you can form is height times width. Width is just the column index plus 1. So if position 1 has height 2, that's a 2 by 2 block, area 4. Track the maximum across all rows and all positions. Why does sorting work? Because if you want to use k columns, you always want the k tallest ones. Sorting guarantees that. No need to try every possible combination of columns. Just sort once per row and scan. Quick example. Single row 10101. Heights are just 10101. Sort descending 11100. Now scan. Width 1, height 1, area 1. Width 2, height 1, area 2. Width 3, height 1, area 3. Done. Answer is 3. The code is clean. First loop builds the heights by adding the row above if the cell is 1. Second loop sorts each row descending. Third loop scans each position and computes height times width plus 1. Return the max. Time complexity is O of m times n times log n because of the sort. Space is O of 1 since we modify the matrix in place. 3 steps. Build heights. Sort each row. Multiply height by width. Save this for your next interview. Follow for daily DSA. Comment your approach below.